Natural disasters have long been a powerful force, shaping human history and reminding us of the Earth's immense power. This video will explore 20 potential natural disasters that are waiting to happen across the globe. By understanding these looming threats, we can better prepare for and mitigate their potentially devastating impacts on human life, infrastructure, and the environment. Number 1. Earthquakes in the Cascadia Subduction Zone. The Cascadia Subduction Zone, located along the Pacific Northwest coast of North America, is a 700-mile-long convergent plate boundary where the Juan de Fuca plate is being forced beneath the North American plate. This subduction process has been responsible for some of the largest earthquakes in history, with magnitudes of up to 9.0 or greater. Scientists have identified a pattern of major earthquakes in this region occurring every 600 years, with the last significant event dating back to 1700. This indicates that the Cascadia Subduction Zone is overdue for a massive earthquake, which could potentially unleash a catastrophic tsunami on the coasts of Washington, Oregon, and Northern California. The seismic risk associated with the Cascadia Subduction Zone has prompted extensive research and monitoring of the area, as well as the implementation of early warning systems and earthquake-resistant infrastructure. Nevertheless, a large-scale earthquake and tsunami in this region could have disastrous consequences for millions of people, causing widespread destruction and economic upheaval. The potential devastation from a major earthquake in the Cascadia Subduction Zone is not to be underestimated, as it could significantly impact cities like Seattle, Portland, and Vancouver. Therefore, understanding the risks and hazards associated with this region is crucial for effective disaster preparedness and mitigation efforts, ultimately protecting lives and minimizing damage to property and infrastructure. Number 2. The next eruption of Yellowstone caldera. Yellowstone National Park, situated in the United States, is home to a massive volcanic system called the Yellowstone caldera. This supervolcano has experienced 3 significant eruptions in the last 2.1 million years, with the most recent occurring approximately 640,000 years ago. Although eruptions of this magnitude are relatively rare, the consequences can be globally catastrophic, affecting climate, ecosystems, and human populations. The United States Geological Survey, USGS, actively monitors the Yellowstone caldera, tracking seismic activity, ground deformation, and gas emissions to detect potential warning signs of an eruption. While the probability of a large-scale eruption in the near future remains low, the effects would be devastating if it were to occur. A massive eruption at Yellowstone could spew volcanic ash across North America, causing widespread damage to agriculture, infrastructure, and human health. Additionally, the release of volcanic gases could lead to a significant cooling of the Earth's climate, disrupting ecosystems and food production worldwide. Despite the potentially cataclysmic consequences, scientists emphasize that the likelihood of a supervolcanic eruption at Yellowstone within our lifetimes is exceedingly low. Nevertheless, ongoing research and monitoring of the caldera provide valuable insights into volcanic processes, helping to improve our understanding of how to mitigate and respond to volcanic hazards. Number 3. The Cumbre Vieja volcanic eruption and mega tsunami. Located on the Canary Island of La Palma, the Cumbre Vieja volcano has been the subject of scientific scrutiny and concern due to its potential to generate a mega tsunami. This scenario involves the collapse of the western flank of the volcano during a future eruption, sending a massive landslide into the Atlantic Ocean and triggering a tsunami that could impact coastal regions along the eastern seaboard of the Americas, Western Europe, and Africa. Although such an event has never been observed in human history, geological evidence suggests that similar flank collapses have occurred in the past. The potential consequences of a Cumbre Vieja mega tsunami are difficult to fathom, as it could inundate coastal areas with waves up to 100 meters high, causing widespread destruction and loss of life. Scientists continue to study the Cumbre Vieja volcano, monitoring its activity and assessing the likelihood of a future flank collapse. While the risk of a mega tsunami remains a topic of debate, the possibility cannot be entirely ruled out. Consequently, understanding the hazards associated with the Cumbre Vieja volcano and improving early warning systems for tsunamis are essential for safeguarding vulnerable coastal communities and mitigating the potential devastation of such an event. Number 4. The San Andreas Fault Line Earthquake. The San Andreas Fault is a major tectonic boundary that stretches over 800 miles through California, separating the Pacific and North American plates. As these plates grind past each other, stress accumulates, eventually releasing energy in the form of earthquakes. The fault has been responsible for several significant earthquakes in the past, including the devastating 1906 San Francisco earthquake. Scientists predict that the San Andreas Fault is overdue for another major earthquake, with some estimates suggesting a 70% probability of a magnitude 6.7 or greater earthquake occurring in the next 30 years. A large earthquake along the fault could cause widespread damage to infrastructure, disrupt essential services, and result in significant loss of life, particularly in densely populated areas such as Los Angeles and San Francisco. To mitigate the potential impacts of a major San Andreas Fault earthquake, California has implemented strict building codes, developed early warning systems, and initiated public education campaigns on earthquake preparedness. Despite these efforts, the consequences of a major earthquake could still be devastating, underscoring the importance of continued research, monitoring, and preparedness efforts to minimize the risks associated with this geologically active region. Number 5. The risk of the New Madrid seismic zone. The New Madrid seismic zone, located in the central United States, is a series of interconnected faults that pose a significant earthquake risk to the surrounding region. In 1811 and 1812, this seismic zone experienced 3 large earthquakes with magnitudes estimated between 7.0 and 7.5, causing widespread damage and altering the course of the Mississippi River. Despite its location in the relatively stable interior of the North American plate, the New Madrid seismic zone remains a significant concern for seismologists. They estimate a 25–40% chance of a magnitude 6.0 or greater earthquake occurring in the next 50 years, which could have disastrous consequences for the densely populated cities of St. Louis, Memphis, and Nashville. Efforts to mitigate the risks associated with the New Madrid seismic zone include seismic retrofitting of infrastructure, development of early warning systems, and public education campaigns. However, the region's relatively low frequency of large earthquakes has led to a general lack of preparedness among residents, increasing the potential for loss of life and property damage. Continued research and monitoring of the New Madrid seismic zone is crucial for understanding the hazards it poses and for informing effective disaster preparedness and response strategies. By doing so, communities in the region can minimize the impacts of a future earthquake and better protect lives and property. Number 6. The Mount Vesuvius eruption. Mount Vesuvius, located near Naples, Italy, is one of the world's most dangerous volcanoes due to its proximity to densely populated areas. Its infamous eruption in 79 AD buried the ancient cities of Pompeii and Herculaneum, killing thousands of people. Vesuvius has erupted several times since, with the most recent significant eruption in 1944. Experts believe that another eruption is likely in the future, posing a significant threat to the more than 3 million people living in the surrounding region. A major eruption could result in massive loss of life, extensive property damage, and significant disruptions to the local economy. Authorities have implemented evacuation plans and are continuously monitoring the volcano for signs of unrest. Number 7. The looming threat of the Alpine Fault. The Alpine Fault, running along New Zealand's South Island, is a major geological feature responsible for the formation of the Southern Alps. The fault has a history of producing large earthquakes, with magnitudes of around 8.0 occurring every 500 years. The last major earthquake took place in 1717, indicating that another large event is overdue. A significant earthquake along the Alpine Fault could have disastrous consequences for infrastructure and populations in the South Island. New Zealand has undertaken efforts to improve earthquake preparedness and resilience, including stringent building codes and early warning systems. However, the potential impacts of a large Alpine Fault earthquake remain a significant concern. Number 8. The potential eruption of Mount Rainier. Mount Rainier, a stratovolcano located near Seattle, Washington, is considered one of the most dangerous volcanoes in the United States. Its proximity to major population centers and a history of producing large lahars, volcanic mud flows, make it a significant threat to the surrounding region. While Mount Rainier's last major eruption occurred over 1,000 years ago, the possibility of a future eruption cannot be discounted. A significant eruption could result in lahars inundating populated areas, causing extensive damage and loss of life. Authorities have developed lahar warning systems and evacuation plans to mitigate the risks, while scientists continue to closely monitor the volcano for signs of unrest. Number 9. The outburst floods from Glacial Lake Imja. Glacial Lake Imja, located in the Everest region of Nepal, poses a significant flood risk due to the potential for glacial lake outburst floods, GLOFs. GLOFs occur when the natural dam of ice or rock containing a glacial lake fails, releasing massive amounts of water and debris downstream. Climate change has accelerated glacial melting in the region, increasing the likelihood of GLOFs and the associated risks. Lake Imja has been expanding rapidly in recent decades, raising concerns about the stability of its terminal moraine dam. If the dam were to fail, a catastrophic flood could impact downstream communities, infrastructure, and agriculture. In addition to the immediate devastation, GLOFs can have long-lasting effects on water resources and ecosystems. Efforts to mitigate the risks associated with Glacial Lake Imja include monitoring the lake's expansion, reinforcing the moraine dam, and implementing early warning systems. These measures aim to minimize the potential damage and loss of life that could result from a GLOF. Continued research, monitoring, and collaboration between local communities, scientists, and government agencies are essential for managing the evolving risks posed by glacial lakes in the Himalayas. Number 10. The danger of a megathrust earthquake in the Nankai Trough. The Nankai Trough, located off the coast of central and western Japan, is a subduction zone where the Philippine Sea Plate is being forced beneath the Eurasian Plate. This geological setting has produced numerous megathrust earthquakes in the past, including the devastating 1944 Tonankai and 1946 Nankai earthquakes. Historical records and geological evidence suggest that large earthquakes occur along the Nankai Trough approximately every 150 years, with the most recent event in 1946. This indicates that another megathrust earthquake could be imminent, posing a significant threat to the highly populated coastal regions of Japan. A large earthquake in the Nankai Trough could result in a powerful tsunami, causing widespread destruction along the coastline and potentially affecting major cities like Osaka and Nagoya. To prepare for the possibility of a Nankai Trough megathrust earthquake, the Japanese government has implemented strict building codes, developed sophisticated early warning systems, and conducted extensive public education campaigns on earthquake and tsunami preparedness. Additionally, ongoing research aims to better understand the complex tectonic processes at play in the Nankai Trough and improve the accuracy of seismic hazard assessments. While these efforts can help to mitigate the potential impacts of a future earthquake, the threat posed by the Nankai Trough remains a significant concern for the people of Japan. Number 11. The eruption of Mauna Loa in Hawaii. Mauna Loa, the world's largest volcano by volume, is located on the Big Island of Hawaii. This massive shield volcano has erupted 33 times since its first well-documented eruption in 1843. The most recent eruption occurred in 1984, and scientists continue to closely monitor Mauna Loa for signs of volcanic unrest. An eruption of Mauna Loa could pose significant hazards to the surrounding communities, including lava flows, ashfall, and volcanic gases. Lava flows can be particularly destructive, damaging infrastructure, agriculture, and natural resources. Additionally, volcanic gases, such as sulfur dioxide, can pose health risks to residents and visitors, particularly those with respiratory issues. The Hawaiian Volcano Observatory, HVO, actively monitors Mauna Loa, using a network of seismometers, GPS stations, and gas monitoring instruments to detect any changes in the volcano's behavior. This allows scientists to provide early warnings and updates on volcanic hazards, enabling local authorities to implement appropriate response measures. Public education campaigns also play a crucial role in raising awareness of the risks associated with living near an active volcano like Mauna Loa. Number 12. The risk of a major earthquake in the North Anatolian Fault. The North Anatolian Fault, NAF, is a major strike-slip fault that extends more than 1,000 miles across northern Turkey. This fault system has produced numerous large earthquakes in the past, with magnitudes often exceeding 7.0. The most recent significant earthquake along the NAF was the 1999 Izmit earthquake, which resulted in over 17,000 fatalities and extensive damage to infrastructure. Seismologists have observed a westward migration of earthquakes along the North Anatolian Fault, raising concerns about the potential for a major earthquake near Istanbul, Turkey's largest city with a population of over 15 million people. A significant earthquake in this region could have catastrophic consequences, including loss of life, widespread destruction, and economic disruption. In response to the threat posed by the North Anatolian Fault, the Turkish government has implemented various measures to enhance earthquake preparedness and resilience, including building code improvements, early warning systems, and public education campaigns. Ongoing research and monitoring of the NAF contribute to a better understanding of the fault system's behavior and inform the development of effective disaster response strategies. Number 13. The catastrophic consequences of the Three Gorges Dam failure. The Three Gorges Dam, located on the Yangtze River in China, is the world's largest hydroelectric power station. While the dam provides significant benefits in terms of power generation and flood control, a failure of the structure could have catastrophic consequences for millions of people living downstream. A dam failure could result from various factors, including earthquakes, structural deficiencies, or extreme flooding. If the Three Gorges Dam were to fail, a massive wall of water would be released, inundating downstream areas and causing widespread destruction to cities, towns, and agricultural land. The potential loss of life and economic damage would be immense, and the environmental impacts would be severe. Chinese authorities have taken steps to ensure the structural integrity of the dam and minimize the risk of failure, including regular inspections, maintenance, and the implementation of flood control measures. However, the potential consequences of a dam failure remain a significant concern for the millions of people who depend on the Yangtze River for their livelihoods and well-being. Ongoing vigilance, monitoring, and investment in dam safety are essential for reducing the risk of a catastrophic failure and protecting the lives and property of those living downstream. Number 14. The eruption of Mount Etna in Italy. Mount Etna, located on the eastern coast of Sicily, is one of the most active volcanoes in the world and is in a constant state of activity. Its frequent eruptions, which are both effusive and explosive, pose significant hazards to the surrounding communities and infrastructure. Eruptions from Mount Etna can produce lava flows, ashfall, pyroclastic flows, and volcanic gases, all of which have the potential to cause damage and disrupt daily life in the region. Lava flows can destroy structures, roads, and agricultural land, while ashfall can impact air quality and hinder transportation. Pyroclastic flows, which are fast-moving avalanches of hot gas and volcanic debris, can be particularly deadly, although they are less common at Mount Etna than at other volcanoes. To mitigate the risks associated with Mount Etna, Italian authorities and scientists closely monitor the volcano for signs of increasing activity. The Italian National Institute of Geophysics and Volcanology, INGV, operates a network of monitoring stations, providing real-time data on seismic activity, ground deformation, and gas emissions. This information allows experts to issue timely warnings and updates on volcanic hazards, enabling local authorities to implement appropriate response measures, such as evacuations or airspace restrictions. Public education campaigns, land use planning, and infrastructure improvements also play important roles in reducing the risks associated with Mount Etna's eruptions. While the threats posed by this active volcano cannot be entirely eliminated, ongoing research, monitoring, and preparedness efforts help to minimize the impacts on the lives and property of those living in its shadow. Number 15. The impending threat of the Lockyer Sea caldera eruption. The Lockyer Sea, A caldera lake located in the Eifel region of western Germany is the site of a potentially active volcanic system. Its most recent eruption, which occurred approximately 12,900 years ago, was a massive event that produced a large volume of ash and pyroclastic material, significantly impacting the local environment and climate. Although the Lacher Sea caldera has not erupted in thousands of years, there is evidence to suggest that the volcanic system remains active. Seismic activity, gas emissions, and ground uplift have been observed in recent decades, raising concerns about the potential for a future eruption. An eruption at the Lacher Sea caldera could have significant consequences for the densely populated regions of western Germany, the Netherlands, and Belgium. A volcanic eruption at Lacher Sea could produce a range of hazards, including pyroclastic flows, ashfall, and the release of volcanic gases. Pyroclastic flows, which are particularly dangerous, could devastate nearby areas, while ashfall could disrupt transportation and impact air quality over a wide region. The release of volcanic gases, such as sulfur dioxide, could also contribute to acid rain and climate cooling. Given the potential hazards associated with the Lacher Sea caldera, ongoing research and monitoring are crucial for understanding the volcanic system's behavior and the risks it poses. The German Research Center for Geosciences, GFZ, is actively involved in monitoring the Lacher Sea region, using a network of seismometers and gas monitoring instruments to detect any changes in activity. While the probability of a major eruption in the near future is considered low, the potential consequences of such an event underscore the importance of continued vigilance and preparedness efforts. Number 16. The Ganges-Brahmaputra Delta, a disaster waiting to happen. The Ganges-Brahmaputra Delta, located in Bangladesh and the Indian state of West Bengal, is one of the world's most densely populated and vulnerable regions. It is exposed to a range of natural hazards, including tropical cyclones, storm surges, riverine flooding, and land subsidence, which are exacerbated by climate change and human activities. One of the greatest threats to the delta's inhabitants is the potential for devastating tropical cyclones and storm surges, which can inundate vast areas of low-lying land, causing widespread destruction and loss of life. The 1970 Bola cyclone, for example, claimed an estimated 300,000 to 500,000 lives and remains one of the deadliest natural disasters in recorded history. Riverine flooding is another significant hazard in the Ganges-Brahmaputra Delta, as the region's rivers carry massive amounts of sediment and water from the Himalayas to the Bay of Bengal. This can lead to extensive flooding, particularly during the monsoon season, displacing millions of people and damaging agricultural land. Moreover, land subsidence, driven by groundwater extraction and sediment compaction, is causing the delta to sink, increasing its vulnerability to sea level rise and storm surges. This poses a long-term threat to the region's ecosystems, agriculture, and the millions of people who call the delta home. To address these challenges, governments, NGOs, and international organizations are working to improve disaster preparedness and resilience in the Ganges-Brahmaputra Delta. This includes efforts to develop early warning systems, build cyclone shelters, and implement sustainable land use planning. However, the scale of the threats facing the Delta requires continued investment, research, and collaboration to protect its people and resources from the disasters that may lie ahead. Number 17. The danger of earthquakes in the Marmara Sea. The Marmara Sea, located between the Black Sea and the Aegean Sea in northwestern Turkey, is an area of significant seismic activity due to the presence of the North Anatolian Fault, NAF, beneath its waters. The NAF has produced numerous destructive earthquakes in the past, including the 1999 Izmit earthquake, which caused extensive damage and loss of life. The Marmara Sea segment of the NAF has not experienced a major earthquake since 1766, leading seismologists to believe that the region may be overdue for a significant seismic event. A large earthquake in the Marmara Sea could have catastrophic consequences for the surrounding coastal areas, including the city of Istanbul, which has a population of over 15 million people. The potential impacts of such an event include building collapses, infrastructure damage, and secondary hazards such as landslides and fires. In response to the threat of a Marmara Sea earthquake, the Turkish government has implemented various measures to enhance earthquake preparedness and resilience. These include stricter building codes, early warning systems, and public education campaigns to raise awareness of earthquake risks and encourage personal preparedness. Ongoing research on the seismic activity in the Marmara Sea region aims to better understand the behavior of the NAF and the likelihood of future earthquakes. This information can inform disaster planning efforts and help to minimize the potential impacts of an earthquake in the region. However, the threat posed by a large Marmara Sea earthquake remains a significant concern for the millions of people living in its vicinity, highlighting the importance of continued vigilance and investment in disaster preparedness. Number 18. The flooding threat in the Netherlands. The Netherlands, a low-lying country with around a third of its land below sea level, has a long history of managing flood risks. The country's vulnerability to flooding arises from its location at the delta of several major European rivers, as well as its extensive coastline facing the North Sea. Climate change, with its associated sea level rise and increased intensity of rainfall events, only exacerbates these risks. To protect its population and infrastructure, the Netherlands has developed a sophisticated system of flood defenses, including dikes, dams, and storm surge barriers. The Delta Works, a series of engineering projects designed to reduce flood risk, is a prime example of the country's innovative approach to water management. Despite these impressive measures, the threat of flooding in the Netherlands remains a significant concern. The potential consequences of a major flood include loss of life, extensive property damage, and disruption of critical infrastructure. To address this ongoing challenge, Dutch authorities continue to invest in flood protection measures and adapt their water management strategies to the changing climate. The Netherlands serves as a global leader in flood risk management, with its expertise and innovative solutions offering valuable lessons for other countries facing similar challenges. The country's long-term commitment to addressing its flooding threats is a testament to the importance of continued vigilance and investment in disaster preparedness. Number 19. The landslide risk in the Canary Islands. The Canary Islands, an archipelago located off the northwest coast of Africa, are known for their volcanic origins and rugged terrain, which contribute to the risk of landslides in the region. The steep slopes and unstable geological formations found on the islands make them susceptible to both small-scale landslides and larger, potentially catastrophic events. Landslides can be triggered by a variety of factors, including heavy rainfall, earthquakes, and volcanic activity, all of which are present in the Canary Islands. In addition to causing significant damage to infrastructure, landslides can also pose a threat to human life, particularly in populated areas or along roadways. To mitigate the risks associated with landslides in the Canary Islands, local authorities and researchers have implemented various measures, such as monitoring and early warning systems, to detect signs of potential landslide events. Additionally, land use planning and infrastructure improvements aim to reduce the vulnerability of communities and critical facilities to landslide hazards. Ongoing research and monitoring efforts are essential for understanding the dynamics of landslides in the Canary Islands and informing appropriate risk reduction strategies. As climate change may contribute to more frequent and intense rainfall events, continued vigilance and investment in landslide risk management will be crucial for protecting the lives and property of the archipelago's residents and visitors. Number 20. The potential eruption of Mount Merapi in Indonesia. Mount Merapi, located on the Indonesian island of Java, is one of the most active and dangerous volcanoes in the world. It has a long history of frequent eruptions, with the most recent major event occurring in 2010, resulting in over 300 fatalities and the displacement of thousands of people. An eruption of Mount Merapi poses numerous hazards, including pyroclastic flows, lava flows, ashfall, and the release of volcanic gases. Pyroclastic flows, which are fast-moving avalanches of hot gas and volcanic debris, are particularly deadly and can travel for miles, devastating nearby communities. Ashfall can disrupt air travel, damage infrastructure, and harm agriculture, while volcanic gases can pose health risks to local populations. Indonesian authorities closely monitor Mount Merapi for signs of increased volcanic activity, using a network of seismometers, gas monitoring instruments, and satellite imagery. The data collected by these systems allows for the provision of early warnings and updates on volcanic hazards, enabling local authorities to implement evacuation plans and other response measures when necessary. Public education campaigns, land use planning, and the construction of evacuation routes and shelters are crucial components of disaster preparedness in the areas surrounding Mount Merapi. While the threat posed by this active volcano cannot be eliminated, ongoing research, monitoring, and preparedness efforts can help to minimize the impacts on the lives and property of those living in its shadow.